Good afternoon. We are really pleased to do the last presentation of the day, and I hope you enjoyed your coffee just after the lunch, and know that it is nearly tea time. We will add a bit of sweetness in the presentation. Indeed, we are going to speak about date palm and the impact of climate change on this crop, and with a study case in Tunisia. So, we are going to split the presentation in 4 parts. The first one will be a general introduction about the date production, where it is grown and how it is grown. Then we will speak about the past and projected climate evolution, the impact of this evolution on the crop, and the adaptation that could be implemented in Tunisia. So let's start with the first part. We choose to speak about date palm, as it is known to be a very resistant crop for hot and dry climate. And you can see on this map that the distribution is located where in region where it is really warm climate. And in blue on the graph, you have the region of origin where the date palm comes from. And you can see that Tunisia belongs to this area. But nowadays, it is even spread in California, in Australia, and even in Europe, in Spain. So this is a map of Tunisia. And you can see in dark orange the region where there are oases and where the date palm is cultivated. There is 4 regions, which are called Gafsa, Gabes, Kebili, and Tozur. And you have the number of repartition of surface of date palm fields in the country. So the biggest region is Kebili in the south, with 58% of the cultivated area of date palm of the country. And we focus on Tunisia because it is one of the major producers of date palm in the world. It is indeed the 10th producer in the world. And it has a really important economical value for the country because it is the second exported product in value and also the 8th production of Tunisia in tons of agricultural production. And you can see on the 3 graphs above that the production has been increasing since the 1960s, and it increased sharply, but it is not due to an increase in yields. It is mostly due in an increase in harvested area, and mostly since the development of the French government and later from the Tunisian government. So now let's talk about the life cycle of the plant, because you might not all be familiar with how a palm tree grows and produces fruits. So we can begin with the propagation of the little plantlet. At the beginning of the year of the life cycle, we take the offshoot, which come from the bigger, the adult palm tree, and we plant them in the new field, and they will start to grow. And we have to wait until 3 to 4 years until the tree is big enough to start to flower and to start to produce a house date palm. The pollination usually occurs in March to May, depends on the cultivar and on the region. And it is a deciduous plant, which means that there is male and female plants, and you have to make a pollination by hand between the male and the female cultivar. And then you wait up to 250 days until the crop ripen for the harvest. And in the meantime, you can have an intercrop. For example, you can have cereals or legumes or whatever you want. And in the summer, you will also need irrigation, as the palm trees are known to like to be the head in the fire and the feet in the water. And you have here the economical life of the palm tree, which represents the time period during which the palm tree is grown. And In fact, a palm tree can grow and can stay alive during hundreds of years, but they only keep it for 50 years because otherwise the palm trees are too high and it's complicated to do the pollination by hand, for example.
So let's talk about climate evolution, past, current, and predicted climate in Tunisia. So for the past climate, we see that there is still an arid climate in Tunisia, and for the prediction is also the same. But we see that the temperature is between 11 to 30 degrees, so high temperature. And also we see that from since the beginning of the 20th century, we see an increase of the temperature of 1.5, 1.4 degrees. So it's a huge change for Tunisia, even in this time. And also we are semi-arid, so we have few precipitation. So 100 millimeter per year is really low, and there is so a dry climate with a little rainy season during the winter.
So now moving on to the projection for climate change in Tunisia, we'll start with the temperatures. So we have chosen the scenario RCP 7.0 because for us it's the more likely to happen. And so if we look at the first graph, we can see the mean temperature anomaly for the end of the century. And we can see a difference between winter, when we will have maybe more 3 degrees, and summer with 5 degrees more. And if we look at the projected maximum daily temperature, we can see the number of the day above 39 degrees will increase, and it's the threshold for dates. Now let's see the precipitation, still for the scenario 7.0. So if we look at the precipitation for the end of the century, we can see a decrease by 10 to 30 millimeters per year. And to have an order of ID, I put the precipitation millimeters per year, so right now. So in our zone, so Gafsa, Kabylie, Toza, and Gabes, it's almost the Sahara, so it's we have really not a lot of precipitation. But in the recharge area, so because the oases are irrigated by the farmers thanks to water coming from groundwater aquifers. Agathe will show you in details, but and the recharge area is in Algeria, in the Atlas mountain, and in this zone we will have a decrease up to 60 millimeters per year. And we will have more fluctuation, so heavier precipitation and fluvial flood. And now another effect of the climate change will be the sea level rise. We didn't have the data for the scenario 7.0, so we took the RCP 4.5, and we can see in Tunisia the sea is expected to rise 0.24 meters in 2050 and 0.5 meters at the end of this century. But the sea level rise leads to a risk of seawater intrusion in the aquifer I was talking about, and I will explain quickly the process. So the aquifer salinity is expected to increase. It was 4.2 decisiemens per meter in 2018. So decisiemens is a unit of conductivity, and it allows us to know the concentration into NaCl. And so in 2050, it will increase to 5.3 decisiemens per meter. So the main factor of this increase are so the first factor is the overdrawing. So it's here we have a farm, and the farmer is this is a drilling, and if you take too much fresh water from the soil, the seawater intrusion can happen. So in one of our region of study is Kabylie, And we know the overexploitation rate is 70%. Another factor is a decrease in precipitation, and I said so it will decrease in our zone and in the recharge area. And the last factor is the sea level rise. So the fact that the sea is rising is a direct factor of seawater intrusion in the freshwater of the aquifer.
So now we have seen the main impact, the main changes in climate in the area, which were the temperature, the precipitation, and the sea level rise. And we are going to focus on the impacts of this evolution on the crop. The first impact that we are going to study is the impact on water availability. And as Leah just mentioned, the water used to irrigate the date palm trees come from two underground aquifers, which are the Intercalary Continental, this one, and then other one is the Terminal Complex. And the recharge area for these two aquifers is in the Atlas Mountain in Algeria and Tunisia. And if, as Leah mentioned, there is a decrease in precipitation both in the recharge and in the OAS area, there will be less water available in the aquifer.
So the next impact is increase in soil salinity. Why there is an increase? Is very simple. You have to feed with water your plantation, but in Tunisia, most of the farmers have access to groundwater, but this groundwater is mostly highly concentrated with salt. So if you irrigate your palm and your ground with salt water, the ground kept the salt in it. So salt water have a negative impact on plant. It reduces growth, it reduces the yield and can be lethal. And even if date palm is high salt tolerant, you have an optimum of salt concentration to 4 decisiemens per meter. But this optimum decreases really rapidly, and even to 10 decisiemens per meter, you have a really bad yield, and no yield at 30 decisiemens. So when you reach high salinity concentration, you can see effect like this picture that is really, really devastating for farmers and a really big problem for Tunisia.
So we have seen for water, there is both a problem in quantities of water and a problem in qualities of water with the salinity. And this is a summary of this impact on the water demand. There is less precipitation, so lower recharge rate of the aquifer, and in the same time sea level rise and seawater intrusion into the aquifer, so the water salinity increases. And there is also warmer temperature, so more evapotranspiration, which leads to water demand which increase, and according to the literature, it can increase up to 40%. But there is not only date palm production, there is also other production, other agricultural production, for which the area planted increase, and this production, this crop also needs water. And there is also urbanization and the development of industry, which also needs water. So the water management will be an issue in the coming years. And the question is, will we have enough water or not for the date palm trees? And it is an important question, because if we don't have enough water, there is a decrease in fruit quality, both for drying, the dates can fall from the tree, there is a decrease in size, and also in changes in the properties of the fruit. And the number you can see on the screen, they correspond to a study where there were 2 plots. The first plot was irrigated with all the water that the plant needs, and another plot with only 50% of the water that the plant needs. And so you see a big decrease in length of the fruit, about 20%, and also a big decrease in the fruit weights and pulp weights of the fruit.
So So the last impact we will present you today, it's the phenological, so the impact of the climate change on the phenological cycle. So the palm, date palm tree is very resilient because it can support temperature from -5 degrees to 50 degrees. But the fruits, the dates, have an ideal range from 20 degrees to 39 degrees. And the minimum temperature for the flowering is 18 degrees. And for the fruit development is 25 degrees. So we can compare, for example, the flowering with vineyards in France, because with the climate change, sometimes it happens that the flourish because the temperature is really high, but then we have a temperature lower, and it can kill the flower and the fruit cannot be developed. And for the phenological cycle, so we will have a problem with the pollination because we have a shift between male and female flowering periods, because the male and female are not on the same palm tree. And the farmers, to adapt to that, they keep the spat in the freezer to preserve it and then do the pollination by hand. And the ripening of the fruits earlier can, at the contrary for the flower, can lead to maturation in a drier climate and with higher temperature, and lead to a drying of the fruit, which can be the fruit can lose quality and even be not marketable. And so this is the cycle of the palm tree and the stage and period, and it could advance by 1 month approximately.
So now we are going to move to the adaptation of the impact that we just saw on the water availability and also on the phenological life of the plant. First, adaptation concerns water efficiency. And to study that, just want to show you the traditional way of irrigation in Tunisia. And it is on the first picture on the left. And this type of irrigation is called surface irrigation by flooding, which means that for the irrigation, they just spread water all over the ground. And this kind of irrigation leads to 30 to 50 loss of water by evaporation or infiltration deep in the soil, and which will not reach the roots of the palm trees. And to face this loss, the farmers usually use twice the amount of water that the plant really needs to irrigate the plant. So if we want, if the water quantity is an issue, then of course the water efficiency, the more effective way is to decrease the amount of water that we use to irrigate the plant. And to do that, the most effective way is maybe to have underground irrigation to avoid the loss by evaporation. So there is different techniques which are listed here: underground drip irrigation, perforated duct irrigation, and also bubbler irrigation. And you have a picture that represents the buried pipeline with pipes that go from one palm tree to another one and spread the water in the ground.
So for soil water salinity, we have a bunch of solutions that we can implement, and the farmer can really specialize for their land. The first one is drainage system. It's like you build some trench on the plot, and the salt can be leached out, because if you flood the plot, all the salt will go away with the water. So this is a solution to decrease the salt in the soil, but it impose maintenance cost. The sand layers you have is an ancient technique that is that the goal is to reduce the capillarity of the salt, and the salt cannot reach the upper layer of the soil, and the upper layer, you have to know, is the most important for plant growth. If the salt do not reach it, the palm will survive and you will have a better yield. You have also salinity resistant cultivar. Some cultivar are more resistant than others, like Calas. This cultivar can survive to higher level of salinity in the ground. And for example, you have this graphic show that Calas grows and the concentration of salt in the soil. And you see that Calas is a little higher, but salinity is still being a great impact on cultivar. For the water solution, you have three main solutions. One is the magnetic treatment of the water. So you reduce the capacity of soil, the salinity, to go always in the upper layer as the sand layer. So you change the property of salt by this mechanism of magnetic, and the water that goes into your plant go down deep in the soil layer. So you protect the upper layer of the ground. But it's a very high cost solution and farmers don't use it so much. You have another solution that is with also a high cost, is desalination plant, but is really focused for a high cost project and is not mainly used. For a low cost solution, and for Tunisia also, because it's really mainly used in Tunisia, you have mixing water. You have two types of water in Tunisia. You have water who come from the municipal water, is really high cost, but you have a low salt concentration. And also you have groundwater, so it's barely free, but it's high concentration in salt. So the idea is to mix the both of the water in a pool, and you will have a result of a water who have a less expensive cost, and also a less salinity concentration.
So the last adaptation we will present you is a transformational adaptation, so integrated adaptation by changing the agrosystem to agroecology, so from a monoculture of date palm tree to a system with three vegetation levels. So the first one is crop. So this picture is from ancestral oasis, and the first level is with crops, legumes or vegetables. The second layer is with olive trees, fig trees, even vineyard, and the last one is so the date palm, and this consists in an adaptation because we know that to lower the water requirements, so to have to irrigate less, we need more humidity and less wind, and this kind of agrosystem is so allow that. The palm tree in this system is a keystone, so it allows the other to exist and to be there, but the other can keep a microclimate to protect it, and that's what I was saying with the phenological impact, because when the fruit is created by the tree, it is sensitive to too high temperature. So one solution to protect the date from temperature that could be too high is, for example, to put other vegetation that create a real microclimate all around it. And so to keep with agroecology, so in this kind of system, the palm tree is not the same varieties everywhere. And for example, in Chenini, we have 30 varieties of palm, date palm, different. And in agroecology, it's always an idea to diversify the varieties, because it can lead to more resistance, resilience against pathogen or against climate variation. And also it represents a lot of co-benefits. For example, in biodiversity, faunistic and floristic, and it is a rural development model. But there is still uncertainties with this kind of model, because, for example, the humidity could be sometimes proposed to development of fungus on the fruit, and it's not the same management of the water, but it's more a politic problem and issue, and it's more the, for example, if Tunisia wants to feed the local population, so agroecology makes a lot of sense. And now.
So to sum up our idea and the problem in Tunisia with the climate change, we have seen that there is three climate changes, like increase in temperature, also diminution of precipitation, and increase in the level, the sea level. This bring a bunch of impacts on the date palm. So as advance in phenology and increase in salinity, that's lead to two main impact on date palm, is a decrease in the fruit's quality and an increase in the yield, and sometimes of the survival of the plant. So there is really the production of the date palm that is impacted. To fight this change, we can implement really much more solution. There is a bunch of solutions that can be implemented and can be really focus on selective farm, so that you can adapt each solution for the problematic that you can see on the ground and on the farm. So if you want to fight salinity for some farm that is mostly affected by salinity, you can use some solution and some adaptation for that. So it really depends of the impact you have on the ground. So to conclude, climate change will have a big impact on date production, and the main impact is fruit quality. Because date palm is still really resilient, it's a plant that can fight the global change, but not the production. The production will be impacted by the climate change. And we have done some policy recommendations. So you have seen all the technique that we speak about, and they need to be implemented on the ground. We need to do some formation for the farmers, because some technique require some competencies, some skills, and we have to promote agroecology, because this solution can also produce that and also help the population, the local population, to be more resilient in food. So this is a really big policy choice that you have to do between increasing the export of date palm and also to the resilience of the local communities. So thank you for your attention.